Hello friends, I am Chandan. Today I start fluid mechanics subject which is important for GATE, ESC, SSC, JEE, ISRO, DRDO, barc and other competitive exam. So this is my handwritten notes, and here the first chapter, that is fluid properties. So these notes are available in the description. You can download it from the description. Okay, now in fluid mechanics I cover the subject. First I cover the topic, the first topic, that is fluid properties. Then the second topic, that is pressure measurement. Third, fluid kinematics. Fourth, fluid dynamics. Fifth, flow through pipes. Sixth, laminar pipe flow. Seventh, boundary layer theory. Next, that is hydrostatic forces on flat and curved surfaces. And the last chapter is dimensional analysis. So today I start the first chapter, that is fluid properties. So before starting the fluid mechanics, we have to understand what is fluid mechanics. The science which deal the fluid matter, that is liquid or gas. So this fluid, this may be liquid or gas in a static or in motion. So this is very important. So the science which deals the fluid matter, that is liquid or gas in a static or in motion. So this is the definition of fluid mechanics. Now then we have to understand what is fluid. The matter whose existence defined pressure and which show continuous deformation under shear stress. So the fluid show continuous deformation. The fluid continuously deform under any shear stress. That is the meaning of this. So this is very important, continuous deformation under shear stress. So in solid, the shear strain is almost constant for a given shear stress. So for solid, we know that Hooke's law, stress is proportional to strain up to elastic limit. So here in solid, the shear strain is almost constant for a given shear stress. In solid, for the given shear stress, there is a given shear strain. Okay, that is also Hooke's law. Next, the fluid show continuous deformation under shear stress, that is shear deformation is a function of time. So this is very important. So this is the function of time. So in fluid, the rate of deformation is more important than deformation. So this is the very important thing, that is rate of deformation. For fluid mechanics, the rate of deformation is more important than deformation. Okay, so this is the basics of the fluid and the basics of the solid, and what is the difference between fluid and solid. Now the next concept, that is viscosity. So what do you mean by viscosity? Viscosity is denoted by mu, and this is the property of the fluid. Property means any measurable characteristics of the system is known as property. So the property of a fluid which offer resistance to the movement of one layer of the fluid over another adjacent layer of the fluid is known as the viscosity. Very important. So which offers resistance. Okay, now we have to focus on the solid. Solid can oppose tensile, compressive and shear load. Fluid has negligible resistance for tensile load, so they oppose the compressive load due to bulk modulus and shear load due to viscosity. But the property, that is viscosity, observed in fluid motion. So let's try to understand this. This is the metal rod considered, and the length of the rod, that is L, and after applies some forces, the length is increases. If you apply some tensile forces, the length is applied increase, that is L plus delta L. So if you want to calculate the linear strain epsilon, that is delta L by L. So we know that from the Hooke's law, that is stress is proportional to strain. So stress, that is sigma, that is equal to, there is a proportionality constant E into epsilon. Epsilon is the strain, linear strain. So from here E, that is the proportionality constant, that is equal to sigma by epsilon. So E is the Young modulus or modulus of elasticity. Very, very important. So if we for solid if we draw the stress strain curve, then so up till some point there is an elastic region. That means here the Young modulus or modulus of elasticity is constant. E is constant every year up till this point. This is the proportional limit. Okay. So after some time, after that the stress is decrease and then increase. In that way the graph is changes. So this is the fracture point. Okay, and this in that region, this is known as plastic region. So here the Young modulus is changes. Okay, so for rigid body, if there is a rigid body and if sigma greater than 0 and if epsilon, that is linear strain, that is tends to 0, so if you put the value here E, that is equal to sigma by epsilon, so epsilon, that is equal to 0, so E value will be infinity. So Young modulus value will be infinite if there is a rigid body. Okay, now suppose this is the rigid surface here, and on that there is a solid are there, and if you apply shear stress tau, that is equal to constant, there is a phi, that is the shear strain. Phi is the shear strain and tau is the shear stress, and this is the graph between shear stress and shear strain. So from Hooke's law we know that, tau, that is proportional to epsilon, that is from Hooke's law. So tau, that is equal to G into phi. So this is phi. Okay, phi is the shear deformation. Okay, so from here G, that is equal to tau by phi. Okay, so here G is the modulus of rigidity. Okay, so now suppose this is the surface. On that surface there is a fluid element are there. So if you apply tau, that is equal to constant, shear stress, that is equal to constant. So for time t1 the shear deformation, that is phi 1. At time t2 the shear deformation is increases, that is phi 2. At time t3 the shear deformation is also increases, so phi 3 is the shear deformation. Okay, so here phi is a function of time. So you see that, so time t1 that is phi 1, time t2 that is phi 2, time t3 the shear deformation, that is phi 3. So from here you can say that phi, that is a function of time. Okay, so from Newton's law of viscosity we see that tau proportional to d phi by dt. So what is d phi by dt? D phi by dt is the rate of shear deformation. So there must be a proportionality constant which is mu. This is mu symbol, mu d phi by dt. So tau, that is equal to mu d phi by dt. So this is the Newton's law of viscosity. So from here mu, that is equal to tau by d phi by dt. So d phi by dt is the rate of shear deformation. So this is the rate of shear deformation. So if d phi by dt increases, then mu decreases. Okay, now here if you see the tau and d phi by dt, so if mu1 is greater than mu2 greater than mu3, then there is a this type of graph is coming to the picture. Okay, now there is a fluid element 1 on the solid on the rigid wall, and this is a fluid element 2 on the rigid wall. Okay, so this is A1, B1, C1, D1. So tau equal to constant for this case, and this is also A2, B2, C2, D2, and tau equal to constant for this case. So for tau equal to constant for fluid 1, there is a shear deformation, that is d phi 1, and for fluid 2 there is shear deformation d phi 2, and there is a displacement dx1, and here there is a displacement dx2. So tau is the shear stress here. So you see that d phi 1 greater than d phi 2. Okay, so from here you can say that d phi 1 by dt greater than d phi 2 by dt. So in that case, the d phi 1 is greater than d phi 2. You see that. So for fluid 1, d phi 1 is greater than d phi 2. So for that, d phi 1 is greater than d phi 2. So d phi 1 by dt greater than d phi 2 by dt. So if this is greater, so the mu will be less. So mu 1 is less than mu 2. And you see that dx1 is greater than dx2. So dx1 is greater than dx2. dx1 by dt that is greater than dx2 by dt. So from here you can say that u1 is greater than u2. U is the velocity. And there are another property, that is fluidity. That is very, very important. That is 1 by viscosity. This is the property of the fluid. And there is another property, that is compressibility, that is beta, that is 1 by bulk modulus, that is k. Okay, so if we compare the solid and fluid, so for solid there is a solid element here, and if you apply the tensile stress, there is a tensile Young modulus coming to the picture. So this is Et, that is the tensile Young modulus. And for fluid, so there if you apply tensile stress here, there is no property for fluid. Okay, so for solid, if you apply compressive stress, then there is a compressive Young modulus. And if there is a pressure for fluid, there is a bulk modulus is coming to the picture. So this is very, very important. Here the bulk modulus under compression is coming to the picture. Okay, and for solid, if there is shear stress, there is a shear modulus, that is G, coming to the picture, that is modulus of rigidity. G is the modulus of rigidity. Okay, and if there is a shear stress of the fluid element, there is a viscosity, dynamic viscosity mu is coming to the picture. So that is why motion is created. So this is the basic definition of the basic difference between solid and fluid. So this is my handwritten notes. You can download it from the description. Thank you.